Hi folks, today I'm going to talk about how to power up your receptacle and lighting circuits using a small, about 3 kW generator. This might be the typical generator that you'd use for tailgating, and it could certainly become the first step in help you out in a power outage situation. About 15 years ago, I was given a 4 kW generator as a salvage item. In between time, I tinkered with the unit and had it running condition, but it had a crack in the gas tank. That year we had an unusual ice storm that caused utility power over a large portion of the state, and our home was without utility power for about 7 days. It wasn't long before I was trying to get this generator up to power our house. I finally got the generator hooked up to the house, and the problem with the fuel tank was solved by siphoning fuel directly out of a 5-gallon fuel tank into the carburetor. It sort of looked like a patient laying on a gurney with an IV in its arm, but we were very grateful to have the little bit of power, and it felt like we were pulling ourselves from the mid-1800s back into the 21st century. Let me assume that we're sitting in front of a TV or reading a book and the power goes off. If you're like me, you'll probably sit there for a few minutes in the dark hoping the power will come back on, but it doesn't. So you make your way to the nearest flashlight and stumble out to the garage, remembering that you've got a generator, a small generator, sitting beside your service panel out in the garage. You stored the generator with the fuel tank and carburetor dry. All you should have to do is to get it running is to pour a little fuel in the tank, check the oil, and pull the cord. However, if you stored the unit with the valve on, fuel tank valve on, and fuel in the tank with the usual E10 gasoline and set for a year or so, since the generator's been used, it may not run because the carburetor is full of gunk. My opinion is that the use of fuel stabilizers is not effective in preventing phase separation of the E10 gasoline. I have found no way to prevent this fuel from failing over a period of time in a ventilated tank. So therefore I recommend just store your generators with the tank empty. All right, with a little 3 kW generator, the standard wisdom is to run an extension cord into the house to power up perhaps a light or two and a refrigerator while you wait for the utility power to come back on. I've never been a fan of the extension cord idea because in winter you're letting cold air in, and in summer insects have free entry into the house. All your 120 volt circuits from your lights and receptacles are terminated in the service panel, as you see behind me here. Why not connect the 120 volt directly into the panel from your generator and eliminate the cord, the extension cords and the open door or window? Since we don't have enough power or the voltage to run our 240 volt devices, I'll start by opening all the 2-pole breakers as follows. Now the only 2-pole breaker that's still closed is the main breaker for the panel. Now what has happened is I've lost power for my heating, my well pump, water heater, all 240 volt equipment. However, the 120 volt circuits, the breakers are still closed, and if we supply power into this panel from the generator, all of these lighting and receptacle circuits will be powered. Now you can't just go crazy and just because you have power on your 120 volt circuits, and let's say you have an electric fryer, an electric unit heater, maybe a coffee maker, and you try to run all of those at the same time, because the generator can deliver about a max, or at least my generator can deliver a max of about 3,000 watts. You should be able to turn on your computer to access websites, say of the utility company, to check to see when service might be restored. Your cell phone charging can all be taken care of. Any light in the house can be operated. I recommend that you have a list of your equipment, perhaps similar to the one I have here on the wall, that just lists the device and what wattage it draws, so that you can kind of mentally keep track as you bring loads on to not exceed the capacity of the generator. I have added to my service panel an interlock to prevent closing of the main breaker while the generator is connected. The generator will come in through this breaker here. In order to close the branch circuit breaker to that generator, it's necessary to first open the main breaker, which I will attempt to do now. And then this interlock device can be slid over, allowing you to move the breaker to your generator to the on position. Now, when you get ready to go in the opposite direction, you see that this breaker, the main breaker here, cannot be moved back to the on position because of this interlock device. First, you must move the generator breaker back to the off position, which is this direction, and then I can slide the main breaker up and reconnect the panel to the utility grid. Several manufacturers of these devices are available, and I'll leave a link in my notes so that you can, if you want to see the device I purchased, be sure that you can identify the make and model of your panel to be sure that the device will fit. Also, the generator input breaker will either be in the position mine is in here, or perhaps on the other side, depending on the mechanical linkage. Now, the reason this linkage is important is that the utility transformer is a bidirectional device. Normally, this transformer drops the voltage, the transmission voltage in this neighborhood, which is usually about 7,200 volts, down to 240, 120. However, if power is applied to the 120, 240 volt terminals of the transformer, then it will be boosted back to 7,200. It's not impossible, if a lineman is working on the transmission line, that he could be exposed to this 7,200 volts when he's expecting the line to be dead. So for this reason, you don't want to take any chances with the injury to an innocent party that might be working on the transmission line. For that reason, I really strongly recommend that anyone doing this consider an interlock device. Okay, at this point, we have already opened the panel, so we have in effect generated a power failure at my house. It's disconnected from the utility power, and let's go ahead and simulate operation on the generator. We'll move the generator out. Incidentally, if you can see, this valve here was added to the fuel line so that I can use it to drain my fuel tank when I'm through with the generator and I put it away from storage. Right now I've got fuel in the unit. I had it operating last week, so it still has fuel in it. It's not stored dry as I talked about. It's important to have the rear of the generator aimed away from your, in this case, your garage, so that it discharges out. Obviously, you've got some CO that you've got to worry about. I have a carbon monoxide sensor here in the garage. I also have a couple in the building, inside the house. So it just from a safety standpoint, don't aim the exhaust into the building. Okay, now I'll bring the engine online, and then you'll see me close the breaker to the generator to supply power into the panel. Okay, now we're entering our kitchen, and I'll flip the switch. Again, the lights come on, open the door to the refrigerator, and this is not to show you our messy food situation, but you see the lights on, our refrigerator is up and running. I keep, again, one of the lists are right here. And one of the kind of bad ones is this microwave, for instance. It's 1400 watts. If you want to bring the microwave on, it's best you don't have anything else much online. So we'll set the microwave, and as you can see, it took a load okay, but we don't have anything else much on except the refrigerator, the overhead light, and this microwave. You got to be careful. Keep an eye on anything that has a heating element in it, because they add up very quickly. For instance, we have a Keurig, and I noticed that the Keurig has a rating of 1500 watts. So that's a pretty heavy load. Again, you probably wouldn't want anything else except that Keurig on at the time you're making coffee. Now, probably the coffee maker, I see we have a Mr. Coffee here. It looks like it's rated for 900 watts according to my list. Again, you must be very careful about how much of these heating loads that you bring on at any given time, because you've got a limited amount of power out there in this generator. And again, it's basically for emergency lighting and communication equipment. Just keep that in mind. Okay, we've just come down to the family room in the basement of the house. I'll bring the lights on. Again, where everything is operating on generator power at the moment. I walk over, push the power button on the TV, and you see it come up. I can't say that this is terribly entertaining, but kind of like watching paint dry, but never mind. But it could sure stave off a lot of boredom. And if you need to communicate with the outside world through your computer, here's one of our computers. It's slowly coming up after the power outage. It's still not online, but you can see it is coming up. So now every circuit in the house has been powered. Every light circuit, every receptacle circuit. Of course, as I mentioned before, we do not have power for the 240 volt circuits. The shutdown procedure is simply to go over, open the breaker to the generator, then I'll shut down the generator and we'll start switching back to utility power. Obviously the power is off now. The breaker for the generator is off, and I have slid this arm back so now that I can turn on the main breaker, bringing us back onto utility power. Now the service panel is live, and I start turning on all the 240 volt devices, which I previously had shut down. Missed the air conditioner unit. Believe I've got everything now. What I've attempted to demonstrate in this video is that you can deliver power throughout your house using 120 volt generation without using extension cords. This approach is intended to get you through a relatively short power outage period. I have a larger 240 volt generator that allows me to use my 240 volt equipment. However, this unit consumes a great deal more fuel. So the use of the small generator allows me to extend my available fuel, particularly if I get caught short-handed without a lot of storage. This home is located in a rural area where natural gas is not available. Also, we don't use any propane fuel, so propane is not readily available as a fuel for my generators. I thank you for watching. Hope this video was useful. Thank you.